All right, guys, so we've worked through the 5.1, which was our compound and simple interest formulas, had some practice and our quiz. Now we're looking through, well, what if we have something that is more of like an annuity, like a long-term type of savings where you can put your money in, get a variety of interests. Many people in the real world will put in money each month to try to build that value. In our scenarios, it's more what's the future value if you have a certain amount of money. So there are two formulas up on the screen. So future value is what the FV stands for. The PV stands for your present value. N is the number of times it's compounded, and this is all up on your screen as well. I is interest, T is time, and then you can divide the PV out and move the PV up top to give you the same equation. It's just what you're solving for is different. And then I'll also show you a website where you can put some of this stuff in, and it will help solve it for you. So there should be 3 different avenues that you can go to solve this. But as always, if you have any questions, you let me know after you check out the video. So let's jump in. The first one says, Josephine wants to retire in 40 years with $750,000. So we know 40 years is going to be important. We know $750,000 is going to be important, and says that's what she wants to have when she retires. So that would be a future value. What would she need to invest now if she has found an account that will pay 5.6% interest? So we know that's going to be important. That's our interest, or our I. So we would want to put our I right here. We could put a T right there. It is compounded monthly. So monthly means it is compounded 12 times a year, since there's 12 months in a year. Assume that she is not going to add any during, some people add each month, but she is not in this scenario going to add anything. So what you would want to do is look and see, okay, well, what all do I know? And if you know that you're going to need the future value and you want to find what the present value is, then we're going to be right here. So this is the equation that we're going to need. So we are going to start just substituting in. So we know that she would like to have $750,000 at the end of a 40-year span. So the interest, let's see, is 0.056. And the number of times is 12, 12, and 40. Sorry, it's kind of going off the screen there. All right, so that is our equation that we would put in the calculator. So we would just simply put all of that in, hit your fraction, and put it in. Let's fill in our chart as well so you can kind of get where I got all those numbers from. So when we are looking to use the online calculator, the way you set this up is you have the 40 years times the 12 months. So there's 480 total times that it would be compounded over the course of 40 years. The interest is 5.6%, so we've already established that. We don't know the present value. That's what we're trying to find. We're saying that she does not add any to it during the month, and we would like the future value to be $750,000, and both of these are the number of times that it's compounded during the year, so 12 times. All right, so you could put all that in the calculator, and it would give you $80,260. Here, I'll write it here, $80,260.99. Or, I told you I'd show you another option utilizing this website. So this link, fncalculator.com, is just financial calculators, and it's dealing with time value of money, or TVM. So what we're trying to find here is the present value. We're saying that there are going to be 0 payments made. So 0 payments, we can just put in a 0 right there. Well, there we go. All right, the future value that we would like to see is $750,000. So you just put that in. The annual interest rate for this problem was 5.6. So we've got that annual. The number of times that it's going to be compounded is 480. So if you're like, where'd that number come from? It was the 40 years, 12 months in the year. And then we're compounding this monthly. So what we have to do is just click the PV, and it tells us that it'd be $80,260.99, which is what we got by putting it in the calculator, $80,260.99. So that is perfectly acceptable to put all in the calculator, or to use that online calculator to be able to solve these. The key is, can you identify the important information? Can you put it in the correct locations? If you can do that, then you guys will have no problem solving. All right, so let's look at another one. Now in this case, Josephine wants to find the future value of an investment. So she has a present value now. So we know, okay, we're using the other equation, meaning we're using the equation that is set up where we want to find the future value because we have a present value. So we're going to use this, meaning there's no fraction like in the other one. So it's a little easier, but it's still knowing what the important information is. So let's see here. $6,000 is the present value. So that's the first thing that stands out. 6.25 is the next thing that jumps out in the equation. Compounded quarterly. So that's 4 times a year. If you think how many quarters do you have to make $1, so it's going to be 4 times a year for 35 years. So you'd say 35 years times 4. So that would give us 140 total times that it is compounded. She is not adding anything that we are aware of each month. We want to know the future value of the payment. We want the future value of the payment to be the $6,000. We know that she would like to know that future value, and we know it's compounded quarterly, so it's going to be 4 times. So if we're setting this up as an equation, using the above equation, you would, here, let me change our color so it doesn't blend together. You would set this up as 6,000. That's the present value. 1 plus our 0.0625 is our interest rate. 4 times a year that it's compounded. So if there's an N there, there's also an N there. And then over 35 years. So you put that all in the calculator, and it will tell you that Josephine will have $52,580.51 in 35 years. So that would be one way of doing it. Or, like I said, you could utilize this, and we say, all right, well, we know the present value here is 6,000. So when you put this in the calculator, be aware that you'll put in the negative 6,000 sign. It just calculates it as far as the future value goes. Would like you to see like what the payment is. Payment period is 0 as far as the monthly payments. Our annual rate is no longer 5.62. It is now 6.25. That is compounded, or the interest rate's going to be yearly. Our period is compounded quarterly. And we have 140 total times that this is going to be compounded quarterly, and we would like to know the future value. Bam. So it's $52,580.51. So either way, it really, whether you're using the calculator that you have, like a TI-30 is what I'm using, and solving, or you can use the online calculator, then you're okay. All right, so for this one, let me get this on the next page real quick. All right, perfect. So for this specific problem, we now have a different set. But again, all these, it's just, can I find the important information? And if you can identify the important information, which I know you guys all can, then you can solve these. So number of payments for number 3. It is 10 years, and it is monthly. So that would be 10 times 12, so we know that that's 120. Our percentage, or our rate, is 3.6%. The principal or present value. All right, so Josephine wants to have $10,000. We currently don't know what she has, so we know the future value is $10,000 that she would like to have. We don't know anything about the amount, like putting in each month, so we're assuming it's nothing. And then it is compounded monthly right here, so we know that's 12 and 12. All right, again, if you can find all of that, then you're going to be totally fine as far as setting it up, because we're looking for the future value. So it's the same equation as the last one, where you take the present value, or excuse me, you're looking for the present value. I said that backwards. There you go. All right, so we're looking for the present value. We know the future value is 10,000, and we are 1 plus the rate of 0.036 over 12, because that's the number of times compounded, over 12, and the time here is 10 years. There you go. So you can put that all in the calculator, and it would give you 6,980.52. Again, another option would be to utilize this, where we don't know the present value, so we're going to get rid of that. We know that we would like the future value to be $10,000, so we put that in there. And the annual rate is 3.6, which obviously you want that rate to be as high as possible when you're making money. This one is now back to monthly, and we are 120. So let's move this back to monthly, and we'd like to know the present value, so 6,980.52. All right, and there's no reason to do both. I'm just showing you both so you get an idea of, using the online calculator or using your TI-30 calculator is another perfectly fine option. All right, so this one is a little different. Still the same concept of picking out important information. Josephine wants to invest $1,250. All right, so she has $1,250 currently. It earns 2.34% interest, so we got that covered. Then we will look at the number of payments, and this is where it's a little different. So we see that it's compounded monthly, so we know there's going to be a 12 in here, but it's saying how many years, and what that means is we don't know the time. So it makes it a little more challenging if you're trying to use the TI-30, but it's still possible, just it makes it to where there's a little more math to do. And then the future value, she would like it to get to $5,000, and this is compounded monthly. So we're back to 12 and 12. So on this particular problem, I would recommend just going straight to here, to where you have your present value, because it tells us that that is $1,250. Payments we don't know, but we do know the future value would be $5,000. Interest rate is 2.34. That is annual for interest rate, and then we don't know the number of periods of times that it's going to be compounded. That's what we're trying to figure out, but we do know it's monthly. So we've plugged in everything we do know. So you would hit periods, and it tells you 711.61 is what would need to go in there as far as your years, or excuse me, the amount of money to take the total. To take the total to divide it by your months. So divided by 12. So T 59.30. All right, so that means that it'll take, close to the 6. All right, so there's some practice problems that you guys can work through, that you're focusing on finding the future value on the first one. The next one, you're looking to find the present value. So there's something missing each time, and with whatever's missing, it'll depend on kind of what you put in and what you're searching for. When it's set up like this, it is usually easiest to use that online calculator, especially like 1, 2, 3, 4, 5, fifth one down where the time is missing. The rest, it's fairly straightforward. You can get it with the calculator in your hand like the TI-30, but that would be our options. All right, so as always, if you have any questions, I am happy to help, so don't hesitate to reach out. All right, we'll see you guys.